Here's an overview of the A/B test process. You have some sort of users and you split that traffic between multiple versions, right? So maybe you're alternating requests between version A and version B of a page. You collect some metrics from both of those cases. You make a comparison, and then you might either make some sort of action or decision. Perhaps you learn something, or maybe you use this information to debug. So for the donation page that you did for Project 3, let's just make this concrete. As the requests were coming in, you split 50% of them between version A and version B for the first 10 requests. And in version B, you had some factors. Maybe you had a different font, image, any number of things. And then we collected some metrics. The metrics we were collecting were basically equivalent to click-through rate. A click-through rate means that out of how many times the page was shown, and the page being shown that's what we call an impression. So however many impressions you have, what percentage of those ended up being clicks to the page. So you collected that information for both versions A and B. You made a comparison, and you simply said, well, whichever has a higher rate is what we should do. And then you took an action, right? You started deploying that page. Let me just give you a couple other examples of what different goals might be in this scenario. So you can see I've numbered all of these different steps, and they were actually walking backwards. I'm going to talk about the outcomes first, and then how we might do comparisons, and then metrics, and then kind of working even farther back, we'll talk about treatments and how we divide up traffic. So that was an example of how you could take an action. Sometimes people do A/B testing just for the sake of learning something. And this is actually in the article that I assigned for the reading today. So you can see that there's a link here to that site on this TechCrunch article from 2014. There's also a link from my website, so you should go there and read that. And maybe we'll get a discussion going about that on Piazza. But they weren't really trying to optimize Facebook at the time. What they were trying to do is learn how people respond to others' posts. And in particular, if other people are being positive or negative in their posts, how does that affect how I will respond in my posts? So, in Facebook you have this news feed of what all your friends are saying. And in the control version, they just did that. A is the control version. They just ran that as usual. And in the version B, they would make a change. They would identify posts that are either positive or negative and show those to you with greater percentage frequency. And then the metric they would collect is that after you've been exposed to this, the next time you make a post yourself, how positive or negative are you? They might do this, like there are certain words that people identify as positive or negative, like maybe happy is a positive word, or things like that. And so they can see what percentage of positive or negative words you use, and they did the comparison, and then they could learn, right? They could learn if emotion is contagious or not, right? So they weren't really trying to change the site anyway. They were just kind of curious what happened. Now, this actually raised quite a controversy when they did this. Well, one of the things we can see is that, we have the two experiments here. On the left, they were reducing negativity, and on the right, they were reducing positivity. And you can immediately see on the right, when you see less positive things on Facebook, well, maybe no surprise, you're less positive yourself, right? And so that's concerning, right? Because maybe they're doing this experiment, maybe they learned something, but maybe they're even running this experiment on people who are depressed or maybe kind of have other things they're dealing with, right? And maybe this is not an appropriate experiment to be running on them. And, if a university were running an experiment like this, they would have to submit this to the IRB, the Institutional Review Board, and try to get confirmation this is an ethical experiment. As a company, they only had to get this approved by some internal ethics board within Facebook itself. So a really interesting article, and the big question is, well, when should companies be required to get approval for this kind of thing, right? It seems like here they definitely should have. But the counter argument is that, well, if they're doing some sort of A/B test to maybe make more money or do something like that, that's also kind of a psychology experiment, right? Any sort of marketing is also manipulating your emotions. And so it's kind of a hard line to draw, right? And there hasn't been enough regulation in this area. So that's something interesting to think about. How could you have reasonable rules around when people could do this kind of experiment. So one other thing that we could use A/B testing for is debugging. Sometimes we might expect that different versions of whatever we're deploying are basically equivalent. For example, let's say you built your web application on version 3.7, and then Python 3.8 comes along, and you want to stay up to date, so you want to switch to that. But your anticipation is that there's going to be no difference in the code, right? Why would there be, right? You aren't really using any new Python 3.8 features. It should probably all be the same. But do you know that? Is it possible that you have some bug that only starts showing up when you switch to Python 3.8? So what you might do, right? Well, you can do a bunch of testing, but you're just kind of testing for outputs. You aren't going to notice things like, oh, maybe when we switch to Python 3.8, certain things run a little bit slower, and then people stop maybe making as many purchases or things like that. So we could use A/B testing to debug these very subtle things and see, like, hey, if I'm doing what I think is a neutral change, is it actually neutral? Or are there some unforeseen consequences that I should be digging into? Okay, so that's the outcomes. Those are the 3 different reasons we might want to do A/B testing. Let's talk about how we can compare the metrics coming off of our 2 different versions. And so for now, we're just going to keep going with that metric, which is click-through rate, clicks per impressions, and just to be a little bit redundant, an impression means that the user actually saw something and had the opportunity to click on it. Maybe they clicked on it, maybe they didn't. And so what you could do if you're doing this kind of experiment is you could build something called a contingency table. And in that contingency table, you have one row for version A and one row for version B. And then in the columns, you can have the different things that they did, right? Either they clicked on it or they didn't click on it. When you did your A/B testing, we kind of kept it pretty even, 50-50. But it's very common that you're going to have your original version, let's say A, that most of your traffic does, and maybe you only have a small percentage. Here I can see that there's 20% of the total users seeing version B, right? So if you look at this table, there's 100 impressions total. So I look at this, and well, first, how many B impressions are there? I guess there were 6 plus 14, so there were 20 B impressions total. And what was the click-through rate? I guess we're clicking about 6 out of 20, which turns out to 30%. So if I look at these numbers here, I have 20, 30%, I could have just done something like this. I could have divided by the click column by the sum of the columns, and I see that, well, B is actually doing quite well. We're getting a 30% click-through rate instead of just a 15% click-through rate. Now, if you're a scientist, like the first thing you're probably wondering is this noise, right? I guess only 20 people saw B. Is that enough or not? And if you've taken a stats course, you probably have this feeling you have to do some sort of statistical test, right? Is this a significant result or not? And it turns out that's actually pretty easy to do in Python. Maybe the best way to do it is that you install this SciPy module or package. So pip3 install SciPy. After that, it's just a couple lines of code. So you can, from SciPy, there's this stats module, so you can import that. And then it has all these statistical tests in there. And one of them that you can run on that contingency table is the Fisher exact test. Right, so I can run the Fisher exact test on that data frame directly, actually. And that returns 2 things to me, and I only really care about the second one, which is a p-value. Right, so when I run this on that click table that I'm showing, that contingency table, I see my p-value is 0.1886. Okay, so what is that? That p-value, what it's telling me is that let's assume the null hypothesis. The null hypothesis is that there's actually no real difference between A and B. They're the same underlying, and I don't know exactly what the click versus no click ratio is, but it's the same for both. And we take 2 samples. There's some noise, right? So if you take some breakdown between click and no click for your underlying model, and apply it to both A and B, what is the probability we get this extreme of a result, right? We would see something like 15% for our A version and 30% for our B version, just by luck, right? Just by kind of sampling noise. Okay, and it turns out that that probability was 18% about. And so what people often do is they'll say, well, is the result significant or not? And to do that, they have to set some sort of threshold on their p-value. For example, 5% is common. And so here I'm looking at, well, 18% p-value, my threshold is 5%. So somebody would probably actually say, no, this is not a significant result. I could easily get a contingency table like that by chance, right? Even if the underlying split is the same for A and B, right? So if that's true, right? So well, the other thing, right? So this is not a false positive what I showed you here, but sometimes you're going to get a significant result, even though that the underlying model is the same. Even though A and B are the same, they end up looking different when we run this significance test, and that's called a false positive. And so one of the things you want to think about when you're doing A/B tests is what is your false positive rate. When you have all these neutral changes, right? B is no better or worse than A. How often are you going to get a significant result? Or it says it's different, but it's really not. And it turns out that these p-values actually work as a kind of false positive rate. So for example, let's say I set my p-value threshold to 5%. What that means is that 5% of neutral changes are going to show up as significant, right? So for example, let's say I made 200 neutral changes, right? So B is not any better or worse. 5% of those times, or in 10 cases, I'm going to get a significant result, right? So you have to be a little careful here. As you do lots of experiments, you're going to get lots of false positives, and you want to do repeat experiments to kind of validate your findings and replicate them over time. Another thing to think about is whether or not your whole testing framework is giving you reasonable p-values, right? We have to make all these decisions, for example, like how do we split up our traffic, right, into going to either A versions or B versions. And so a best practice is that you should occasionally run AA tests, right? Well, not occasionally, you should do it a lot. Right? You should run all these AA tests where you have A and B are actually, you know, they're exactly identical. And what you should make sure is that that only 5% of these AA tests show up as significant, right? If we set our p-value threshold to 5%. If we were getting a lot more or a lot less than that, we know we did something really wrong in our framework, right? Maybe we aren't really dividing traffic fairly or something like that, or maybe the experiments are interfering with each other. Okay, so when I do these tests, there's really three outcomes I could get if I'm looking at both the metric, which is CTR, and significance. One is that I can say A is significantly better, or maybe B is significantly better, or there's going to be a lot of cases where neither wins. And in that case, we have to think about, well, what are we going to do? So maybe I'll just give you a moment to think about that yourself. What would you do in this situation where neither is statistically better? Try to come up with at least one idea. So maybe the scientist type is trying to say, well, we should collect more data, right? We can run a bigger experiment, and that's often the right thing to do, right? But not always, right? Sometimes we want to make a decision soon, and there's a cost to running these experiments, right? I only have so many users, and I want to run other experiments on them too, right? I want to run other A/B tests, and if I'm trying to get a bigger sample for this one, maybe I can't do as many other experiments. The other thing you could do is if you say, hey, I just have to make a decision, right? I mean, people are going to keep going to the website and I have to show them something. Maybe I just ignore significance. Maybe I just choose whatever the best CTR is, right? I have to show them something. Why not, right? There might be other things that might weight you in favor of either version A or version B, right? If we can't really tell. For example, I might assume that if I've been having version A on my website for a very long time and version B is new, version A probably has fewer bugs, right? It's maybe people have kind of done more troubleshooting with it, whereas B is a bit of an unknown, right? So I might just default to keeping version A unless B can really prove itself as the winner. There's maybe other cases where version B might be better, maybe like that example I said where we're upgrading from Python 3.7 to 3.8. I kind of expect that neither of those is going to win. but we want to keep current with our software, right? So maybe I do that. Or maybe another example is that maybe version B, somebody was running through and just kind of simplifying the code without trying to make it behave differently or faster or slower. In that case, maybe I want the simpler code, so maybe I'd choose B in that case. So let me just give you an example of a real A/B test that Bing did. This was mentioned in that keynote talk I talked about. And what they did is do you see the difference between these two versions? The one on the left has underlines in the link, and the one on the right does not. And I'm curious, which one do you think people click on more, right? Sometimes people do a search, and after they do the search, they don't click on anything. And so that's not really good, right? It means the search engine isn't really helping people. So I'm curious, which one of these do you think people click on more often? Version A or version B? It turns out that version A is actually clicked on more, right? So who knows why? Maybe the hyperlink underlines make it stand out more. People click on it. And so you might think, well, okay, the evidence has spoken. We should choose version A. Bing actually did this experiment for many months recently, and so it's a very clear result that they did this. But ultimately, if you go to Bing today, they decided not to do that. They have version B. Same thing for Google. If you go to Google results, they don't show underlines immediately. And I think the lesson here, so I guess they debated this a lot, right? It went high up in the company, and somebody eventually decided, with a lot of authority, that, hey, we're going with version B. And to me, like, version B looks better, right? To a lot of people. I mean, version A looks like it's out of the 90s. And so there might be these other things, right? Maybe even though people click on version A more, maybe there's these downsides, right? Maybe it hurts your brand. Maybe Bing ends up looking less modern. And so I think the lesson here is that metrics should inform humans, right? It's good to know which of these people click on more, but that doesn't mean we should just kind of unthinkingly choose the version with the highest click-through rate. We have to consider other factors, like what will this do to our brand in the long run. All right, so that's how we can compare metrics, and I've just been using this one example of click-through rate, but there's so many other metrics that we could be computing and then comparing. Okay, so things to measure. Well, clicks was one, and maybe I've had this implicit assumption, right, that if we get more people to click, that's a better thing. But it's not always true. Sometimes clicks are a bad sign. Can you think of at least one case where clicks are a bad sign? One thing I can think of is that if maybe you're clicking a button that says unsubscribe, right? That's definitely bad. We never want people to click that button. Right, so clicks are not always good. On Bing too, right? If people are searching for things and they just keep clicking on different pages and never see anything, that's probably not great. There's all these other signals we could use. For example, let's say there's an article and you're trying to see how well your article went over. If people actually scroll down, that's a signal that they're reading, right? They aren't really clicking on anything, but websites can do that. They can record whether people are scrolling and report that back. I guess, you can't discuss with your neighbor. What are other ideas? What are other things that we could measure for our A/B tests? Try to write down at least like 2 or 3 ideas. So maybe here's a really important one. What are people purchasing and returning, right? I mean, often if you're running a for-profit website, I mean, that's what keeps your business operating, right? There's these other things. Maybe you show some sort of video that's some sort of promotional thing, and it's not really designed for people to click on, but you want to have some way of gauging whether people are interested in it. For maybe sometimes what people will do is if they're interested in something, they'll hover their mouse over it. They kind of move their mouse on top of it, but they don't click. They can record that and report that back. Social media, are people sharing this thing, or maybe liking it or upvoting it? Are people commenting on it? If they are commenting, can you kind of identify whether those comments are positive or negative? You can imagine a lot of combination metrics. For example, when Bing, right, is a search engine, if they're trying to measure the quality of their search results, what they're ultimately trying to do is help people find information. So what they consider a positive is that somebody clicks on one of the suggested links and they don't hit the back button within 30 seconds, right? So they actually went to a page that had some useful information. If they click and immediately come back, maybe that's actually a negative sign that it wasn't a very useful result. Here's a couple of use cases I want you to think about how different actions you could take might kind of affect multiple metrics. So, well, I guess I've been talking a lot in terms of just like web pages, but a lot of kind of online companies will also be sending emails, right? So let's say you're doing this A/B test, and in the B population, everybody gets twice as many emails, maybe kind of spammy emails, like, hey, you should, here's a promotion, you should buy our product. And so I wonder with the group B, what are they going to see in terms of both subscribe, unsubscribe, and then the purchases and returns? My intuition is that if we send more spammy emails like this, we're going to sell more in the short run. And they try to talk about this in the keynote talk too. They're going to buy more in the short run, but you're also going to get people unsubscribing, right? That which hurts things in the long run. And so you have to be careful, right? If we're just kind of looking foolishly at one metric, like short-term purchases, you're going to miss some factors like that. And so you can imagine inventing metrics that combine these, right? Can we somehow say put a dollar value on what a subscription is worth to us, and then weight that, right? How many unsubscribes do we get versus how many purchases do we get? Here's another example. Let's say that I have a link to a product page, and that link says like, buy now for $300, and I change that link so and maybe it doesn't say the actual price, it just says on sale, buy now, right? But it doesn't say the price. You might imagine that removing the price will make more people click on it, right? Maybe the price scares some people away, but eventually everybody figures out what the price is once they get to that page, and they're not stupid, right? If they go and the price is not worth it to them, they aren't going to buy it, right? So if you do make a change like this, maybe you get more clicks to the page where people actually buy, but maybe they drop out later. So a couple lessons that they learned at Bing is that, in the second case, it's really easy to shift clicks, right? I can make people click on the page to go that kind of shows my products actually buy, but that doesn't mean they're actually going to buy, right? Kind of depending on the wording, they're just going to drop out at various points from where I'm first, they visit my website, or they actually buy something. Right, so that's easy to do, and make sure you aren't just shifting things around. And then the second one is that we often care about these long-term effects, right? Maybe I've sent too many spammy emails, and after a few months, somebody gets sick of it, and they finally unsubscribe. It's really hard to run those kinds of tests, right? It's very noisy, especially if you're running other tests during that time. And so I think all this A/B testing stuff, right? It feels like very scientific, and we just kind of want to follow the metrics, but don't. You have to use your common sense and trying to think about these side effects, right? The metrics should be informing you. They shouldn't be directly making the decisions. So some recommendation that you should do if you're doing this is that you should decide beforehand on an OEC. An OEC is an overall experiment criterion. This is going to be like the one thing you really look at when you're trying to decide if version A or B is better. You can see with all these metrics, it's very easy to do your experiment first and then find afterwards a metric that supports you. But then you're just kind of fooling yourself, right? So you have to decide this up front. At Bing, in that keynote, they talked about how they really only have 4 OECs, and you have to pick one up front before you do your experiment. But in addition to that, they have thousands of debug metrics, right? So maybe the OEC tells you like whether we should do something, but these other metrics will maybe tell you why. Why did version B not work, right? So you want to determine that OEC up front, and you want to try to consider the cost as well as the benefit. So Ron Trifoni made this point that if you make something bigger, more people will click on it. Simple as that. Now, of course, there's downsides to making everything on your site bigger, right? If you make it bigger, well, then other things get shoved off the page and you have to scroll down, right? And maybe you want people to click on those things too. So you have limited real estate on your site. You want to kind of use that, judiciously. And so maybe you want to think about things like, well, what is my click-through rate? And maybe divide by how many pixels or how many square inches, I should say, we need to actually show the content. one other issue, right? We kind of talk about these simple things like, oh, we know the click-through rate, we know what people saw and what they clicked. The problem is that there's all these bots online, right? So there may be bots that are scraping our website, and I actually just recently learned that over half of all Bing traffic is from unauthorized bots, right? So it's mostly not human, and they're all maybe creating, here I've drawn a table, this is kind of like a record of what pages people are visiting. And so before you try to compute something like click-through rate, you want to have some sort of bot detector that tries to filter it out. And that's not going to be perfect, right? You can see here on the right that that cleans up the data a little bit, but there's still some bot traffic in there. But whatever, we do the best we can. And so, I talk about simple things like click-through rate, but there might be all these filters that go before that. And so if you're trying to do these kind of comparisons, especially maybe across different experiments, and you want reproducible results, that's an important part of it. You have to think about, well, what kind of filtering or data cleanup did I do before I computed my metrics, and make sure that if you're doing any other experiments that you want to compare against, they do the exact same filtering, right? If I want to compare across two experiments, I better make sure that maybe I use the same version of that bot detector, even if the bot detector has changed over time. All right, so that was metrics. Let's talk a little bit about treatment. What exactly are we changing in version B? Are we making the font bigger, a different color, whatever, right? So we're always going to be running these two variants side by side. One we call the control, or A, and then the treatment, or B. And both of these actually consist of one or more factors that we changed. And that could be any number of things, like maybe I changed the wording. Sometimes people will introduce slowdown. Of course, nobody thinks that slowdown is going to make things better, so this is not really in order to make an action, but this is to learn something. If we make our website faster, will that turn into money eventually, right? So people might kind of intentionally slow it down for the B users just to see what happens. There might be changes that are invisible to the user, like updates. What other factors, maybe just list down as many as you can right now, what other factors might you put into your treatment? So here are some. Let's say you're sending emails. What time of day do you send it? Do you send it at dinner time, in the middle of the night, so people see it first thing in the morning? Lots of choices there. All kinds of details about graphics design, right? Maybe you're actually designing full graphics or logos, right? Maybe that's a very time-intensive effort. Maybe you're on Amazon, right? And you have a recommendation system. You're showing people different products they should buy. You could develop different machine learning algorithms to make those suggestions, right? And you could try alternatives. Maybe if you're buying things, there's a sequence of steps you need to do, and you can try different sequences. Maybe you're switching out what database you're using on the back end. Maybe you used to use MySQL database, and now you're switching to another one, such a PostgreSQL database, right? Maybe the database is faster for some kinds of queries and slower than others. What is that trying to do for the bottom line in terms of like how happy users are and what they're willing to pay? And what I want you to think about here is that there's a big time investment to doing a lot of these experiments, especially for like things like graphic design, right? I have to actually make multiple complete designs and maybe combinations of icons. And so there's almost a social aspect to this. You have to get designers used to doing a lot of work and building multiple designs, and just knowing up front that at least half their work is going to be thrown away, right? That's a good lesson in general in life. Don't get too attached to your work. I often see students doing that on their projects, right? They started on one path, and it turns out to be kind of a hairy mess. And then even when they learn that there's maybe a more elegant way to do it, they still want to salvage what they were doing, right? Rather than kind of starting fresh. So in general, right? Like any kind of creative work is very experimental. So you just have to get in the habit of, hey, maybe I'm going to throw this away, and that's okay. The counterpoint to that is there's also plenty of low-hanging fruit, right? Things like, hey, if I change the size of some font or what color it is, it's very low effort. And so Ron, he said this thing which I think is very insightful, which is just stop debating. Often it's lower effort to just get the data, and then right? Don't argue about how people respond to red font or blue font, right? That's just kind of you don't get anywhere, right? Just the data. Okay, so the other thing is that when we have these treatments, we're changing one or more factors, and that's kind of a hard decision, right? Do we do a series of experiments where we change one factor at a time, or do we change a bunch of things at a time? Here I kind of have a simple example where I'm just looking at click-through rate, and I see that in the top left I started off, so this is version A, with small black text, and there was a 10% click-through rate on that, and I can change the color and or the size, right? So one thing I could do is I could run two A/B tests, one where I'm changing the color only and one where I'm changing the size only, and I could do that. It's called one factor at a time, or OFAT. The other option is that I could introduce two factors at a time. I could go straight from small black text to large red text and then see what happens. And there's benefits to both of these. In the second case, maybe I find the best design and I can kind of quickly get to that, but I didn't really learn what was important, right? I don't know if that, it's possible that all that matters is that the text is red, and I could have had small red text and had just as much benefit while leaving more space on my page for other things, right? So I didn't really learn as much, even though maybe I ended up with a good design. The disadvantage here with one factor at a time is that there might be interactions between these factors. It's very possible that maybe changing to red text makes it worse, changing to black text or changing to large text makes it worse, and only when you do both of these things at the same time do you actually get the benefit, right? So in that case, I maybe go up to 15%, whereas just doing one of these other things would drop me to either 9 or 8, right? So there's kind of these trade-offs here, right, that I have to think about. It probably, most of the time, it makes sense to do one factor at a time, and then occasionally, right, maybe you will try these sweeping changes where you change lots of things. Something people often refer to as hill climbing. It's kind of an analogy here. What you might imagine is that, so as you're kind of walking around through the mountains, the higher altitude you are, or the closer to the peak, maybe that corresponds to something positive, like a higher click-through rate. Okay? And you're just kind of hiking in the mountains, and maybe it's foggy, you can't see, but you still want to try to find that peak by making one change at a time. So maybe if there's like two dimensions to it, like font size and color, right, I can actually imagine that as an X and Y, but it also works for many dimensions. And so there's different strategies, right? One strategy is that you make one small step or one change at a time and see, is click-through rate higher? Is it higher? And you keep making these changes, and eventually you're going to end up at some sort of peak if you do that, right? So that's generally a good strategy. But the counterpoint is that maybe there's multiple peaks, and if you only take one small step at a time, you're going to get to a small peak, and maybe you stay there, right? Occasionally, you want to shake things up, make a lot of big changes, and maybe you'll actually find there's another hill with another peak that's better, right? A complete redesign, different set of decisions that are kind of coherent with each other ends up being better, right? So you have to do a mix of these things. OFAT's probably good most of the time, but sometimes you have to make sweeping changes. Here's something that you probably wouldn't really see in experiment design, outside of a computer science setting. But often the control and treatment can disrupt each other, right? I mean, well, these are two versions of the code, but maybe they're running on the same computer. They're probably using the same database, and you can imagine all kinds of problems with that. For example, let's say the version B just swamps the database with unnecessary requests, right? It just has all these unnecessary queries, and it slows the database down. Well, guess what? If version A is doing that too, and the database is running slower, B can make A slower, right? So if B kind of brings them both down together, our A/B test doesn't really show that something changed, right? So you want to do all this kind of performance monitoring and just kind of have common sense, right? Does it seem like something's fishy, right? Did kind of version A get worse suddenly, just coincidentally when we started our experiment? Maybe a more horrible case is the version B has a bug in it that crashes the whole server. And hey, guess what? A/B testing makes them look the same. Neither of them are serving many requests because they're usually down, right? So you have to be careful about that. Here's another thing that people worry about a lot, and that's what if humans like novelty, and what if the thing that is good about version B is just that it's different, right? It's not that it's inherently better, but it's refreshing to the users. So what will you do about that? So here's a timeline about how people might be doing experiments. you see that originally people started on version X, which is A, the control, and on the y-axis, I'm just showing what percentage of requests are going to either version X or version Y. So you see that as we're doing our experiment, 90% of it is the control, and we kind of put 10% to the treatment. And I'm not really showing the click-through rate or anything here, but we have that information somewhere. And let's say at some point we determined that version Y, which was only getting 10% of the traffic, is doing better than version X, which was getting like 90% of the traffic. So at that point we want to switch to Y. But people will often do then is they'll do like a flipped A/B experiment, right? So what used to be our control with 90% becomes our experiment with 10%, right? So we'll keep running that old version for 10% of the people, and we'll just run that experiment a long time, right? And then we can see if somehow that one starts doing better, maybe we want to switch back to that original version. Okay, so there's the last part here, which is, we have built our two versions. How do we determine who sees which one? For your project 3, it was simple. You just split the request 50-50. What people often want to do, though, is they won't go straight to 50-50 because maybe version B is a lot worse, right? If version B means less sales, you probably don't want to immediately show version B to half of your customers, right? That could have a big impact on the bottom line. So here's what people often do. So here I'm kind of showing time as we're doing our experiment. So we have version A, and then version A is actually pretty good. People click on version A about 40% of the time, and they don't click on it about 60% of the time. 40% is pretty great, actually. And when we introduce version B, we're going to have a very slow ramp up, right? We're going to give it very few of the requests and do it, slightly more over time, right? So kind of all of this traffic that was going to A is starting to go to B. But I can very quickly see, right, even though I haven't fully ramped up B to 50%, that the click rate for B is going to be a lot less than 40% that we get for A, right? So rather than fully ramp this up and give all our users a bad experience, we're just going to abort that early, right? B is not a good option. Maybe it was a bad design, right? In which case we throw it away. Maybe our metrics show us that there's some bugs, right? Maybe it doesn't work in certain browsers or things like that, in which case maybe we'll go back, maybe do a little debugging, and then try another slow ramp up after we fix some issues. The other thing we have to think about is what exactly we're going to split. So here I'm showing a few different users, and they're each sending a lot of requests to our web server. I've kind of drawn that as a timeline, right? Because we're going to get some sort of log of all the requests that people have sent us. And then we have this decision, right? Do we want to, when we're serving version A and B, do we want to just alternate in requests? And maybe that means that a user hits the page and they see version A and they refresh and they see version B. It's a little weird, actually, right? You probably don't see that too often on real websites. Probably what's more likely that they want to do is, if they can, split the users, right? So this user is always trying to see version A, and this other user is always trying to consistently view version B. And that raises a really tricky question. I mean, how do we actually figure out who a user is? And if I asked you this, based on what we've already learned about the internet, you would probably come up with a reasonable suggestion of, well, let's look at their IP addresses, right? That's what I would probably think. And it turns out that that doesn't work too well. And the reason why is that people are often inside of these organizations, and within the organization, everybody kind of has their own IP address allocated to them. And maybe if they're sending web requests between their computers within an organization, everybody knows those IP addresses. But when they want to send traffic to the internet and it's all going out, there's this piece of software called a NAT. And I'm not going to really get into too many details about that. But what it really ends up doing is that there's this shared IP address for this whole organization, and everybody who's doing work inside of that organization to the outside world looks like they have that same IP address, looks like it's somehow shared. And so if we did this web application, which might be serving many different users in the same organization, they all look like they have the same IP address, right? So that's one issue. Another issue is that your global IP address, if you have one that's not shared with others, can often change, right? It's actually kind of an exception rather than the rule that you'll be paying for a global IP address that doesn't change, right? So IP addresses are not going to work that great, actually. Um, some websites you have to sign in to use them, and then the server knows exactly who you are, no doubts about it, and that's the best, right? So that's what we want. You should use that when you can. But the thing is, you can't always use that. For example, maybe you're building this website, and you go to the website, and there's option to create an account, and you want to optimize that. How do you make the create account button look, or the text about it, and figure out how to make people create accounts? Obviously, if they haven't created an account yet, you can't use this to A/B test it, right? So you have to have some other technique. That technique is actually often cookies, right? Maybe you've heard of cookies. Cookies are just really information that websites can ask browsers to store on a user's laptop, and then when there are requests later, they upload it. So we can kind of keep track of who users are and track them. It's actually really easy to do in Flask, right? So here's an example of some code that's using cookies. For my homepage, my index, you can see I'm printing off cookies. Cookies is just this big dictionary. I can look up keys in it, right? So I could look up the user ID and cookies. You can see later I have this response. I'm not really quite returning a string like I normally do. I'm returning this response object. In the response object, I'm putting the string hello, right? Before, maybe I would just return hello. The reason I'm returning a response object instead of a string directly is that I have the opportunity to set cookies, right? So I can set the user, and I'm actually saying there's a typo which I should fix right now. Instead of user, that's like user ID. I can't change that. Sorry, that's user ID, and I can just set that, right? And however, maybe I generate it based on time. Probably not great, but something, right? And then every time they come back here, I can see, oh, this is the user I saw before. Okay, so this is a pretty good option. It's more accurate than IP address. There's all these concerns though, like where it can fall short, and you should just be aware of these. One is cookie churn, right? Eventually cookies expire and they get new cookies, so you might, maybe you've tracked somebody for a while and now all of a sudden they seem like they're somebody else. If they switch web browsers or laptops, that's also going to look like a new user even though it's the same person. If you open up something in incognito mode in Chrome, that's going to be kind of not uploading any cookies, right? So it's a little harder to tell who people are. And then finally, recently there have been all these local laws that limit your ability to track people without informed consent, especially in the European Union. I don't know exactly what the laws are, but you can get in trouble if you don't tell people that you're using cookies and get their permission to do so, right? So that's a tricky issue, right? International law, and I'm not going to really pretend I'm an expert at that, but just be aware that there are some rules around that, and that it's always evolving. Okay, to summarize, right, we have this big picture, and just working backwards again. There's many reasons we want to do A/B experiments. We want to either make decisions, just to learn things for the sake of learning, debug things. We want to make comparisons, and instead of just simply saying like, oh, this is the best metric, I'm going to go with it, we want to look at significance to figure out if it's probably a meaningful result or if there's a good chance it's just noise. For metrics, we saw that there are often kind of simple metrics like, oh, what's the click-through rate? Or maybe combinations, right? Combination might be how often does somebody hit back after they clicked your link? Or how can I weight purchases against unsubscribes? When we do these metrics, we're going to have to we're going to have to clean up our data in some uniform way, right? To maybe eliminate any traffic from bots. For metrics, you should choose one metric up front. Your OEC, that really determines your overall experiment criterion. That determines how you're going to make your decision in the end, right? Or maybe it's the most important thing to you. And you should think long term, right? I mean, don't chase clicks up front if it's going to ruin your brand in the long run. These metrics are used to measure different treatments, right? With treatments, we have one or more factors, things like changing font size or color. Some factors require a lot of coding and design, right? Maybe it's making a whole image or logo or whatever, right? So you have to get invested in doing work that's really just an experiment. Maybe you throw it away. When you're exploring these things, you can do treatments where you do one factor at a time. That's probably the best for learning about what individual factors do. Another concern here is that there's often novelty. Maybe that's the real factor. And so you often want to do a flipped A/B test. After you've made a decision to switch, keep running the old version on some users and see if that kind of comes back as being better. Finally, we saw how we'll split traffic across our treatment and our control. A couple lessons there. One is that we want to always ramp up slowly, right? It's possible that version B is horrible and it's going to lose us a bunch of money and customers, and we want to detect that early and not run our full experiment, right? Maybe often you're running a business and you care more about that than maybe what you're learning, right? Maybe that's your goal. And then finally, we have to figure out how to divide traffic between version A and version B. And you can think about either splitting requests, kind of the simple and easy thing to do, but not great, because then maybe somebody keeps refreshing and they see different things, or users. And the challenge there is, well, how do you distinguish them? Like IP address isn't great. Accounts are the best. Not everybody has an account. And then cookies, which kind of work pretty well, but they have all these kind of legal issues and other trickiness to them. All right, well, have a good day.